Hello. Hi guys, good morning. Welcome back to a new video. In this video, problem maximum good sub-array sum. Now, I think it is one of the best problems for me if I want to ask in an interview because it involves many such small concepts. Again, if you know very small concept which we have studied in the array, if you are not studied, go and watch Aryan Mittal playlist. In that, we have studied many such kind of problems. It is just the compilation of all of those techniques. We will see how this can be done. Let's quickly have a look. Now, we are given an array nums of length n and a positive integer k. Okay, array nums, length n and one integer which is k. Nums and one integer k. Now, a sub-array of nums is called as good. We want the sub-array of nums is called good if the absolute difference between its first and the last element is exactly k. Which means if I take this as a sub-array, this is let's say the ith element, this is let's say the jth element. Then nums of j minus nums of I or nums of I minus nums of j, anything can work, but take the absolute difference. If that is equal to k, okay, then it can be good, but on all such good sub arrays, please find the maximum sum of all such good sub arrays. What we mean by good is something if the ing difference of not the ing coordinate difference but the ing values difference, if it is actually equal to your k, it's actually a good sub array and this maximize the sum. Now if we just break the problem, first will come the simple arithmetic. If I say y minus x absolute value is equals to k, so you can represent the same thing as y minus x can be k or minus of y minus x can be k, which means minus y plus x can be k. So I can simply say that my nums of j, if you just write nums of I minus nums of j, okay, nums of I minus nums of j, it can be k, or I can say my nums of I, okay, minus my nums of I plus my nums of j, it can be my k. So now as simple as that, you will simply use the logic of what you have seen in problems like two sum and stuff. Simply, what we mean by two sum, we are saying if I am at j coordinate, if I am at jth index, right? If I am at the jth index, why I am saying coordinate? Because the last problem I did was question number 4, which I gave the video recently, and that was coordinate based. But cool. We have our jth index. Now in that jth index, let's say you are at the jth index, you have to find the specific ith index whose difference, again absolute difference, will be equal to k. So now let's imagine you are at the jth index, you have to find the ith index. So you can simply say that your nums of j, you have to find this nums of I. So this nums of I will actually become your k plus nums of j, and again with this fact, your nums of I, it can become your, again this will go in this side, this will go in this side, it will become your nums of j minus k. So your nums of I, which means, okay, if I am at the jth index, I know my nums of j, I know the k is absolute for sure, so I know that this is my expected nums of I. This is my expected nums of I, which is nums of I can have two values, either nums of j minus k or nums of j plus k. Let's name it as expected 1 and this is expected 2. I have two expected values. If I find those expected values, which means my jth and ith index values absolute difference will be exactly equal to k. That is the first condition where you use arithmetic and two sum concept. Okay, now what by using, now in two sum you remember, okay, I know that, okay, I have to find nums of I, right, which means I will be getting, okay, this j I am right now at, so this nums of j is something of value, let's say value is 2, so k plus 2, let's say k is 3, so k plus 2 will be 5. So I know I have to search for a 5 in the previous part. Okay, in this part you will search for a value, okay, 5, let's say, which is nums of I. Now, okay, I will search for a value, but Aryan, I need index. But bro, why you need index? Because Aryan, you remembered, I want to find the sum of a subarray. Oh, so now your next task became that how will you efficiently find the sum of any subarrays? Now in this, when you have to efficiently, which means in O of one time, find the sum of any subarray whatsoever, thus you make a prefix sum. What this prefix sum means, if I have an array, let's say 1 2 3 4, and if I just take the prefix sum as, okay, by default, if you remember, in the prefix sum I have by default as 0, then 0 1 3 6 and 10. As you can see, okay, 1 was directly copied and pasted. Prefix sum is nothing but you just take the prefix. Okay, 1 2, you see, you can see sum is 3, 1 2 3, the sum is 6, 1 2 3 4, the sum is 10. So that is how a prefix sum works, and you can simply go and add in the previous prefix sum value which stored this value, and add this current value, you will get the new sum which is 10. So with the prefix sum concept, if I go and ask you, bro, what is the, if let's say your j is here and bro your I is here, you want to find the range, okay, this specific range, you want to find the answer, what you will do, okay, you will simply say, okay, this is my jth index, I know this is my ith index, so I'll go on and say, okay, this is my prefix sum of j, I'll go on my prefix sum of I minus 1, which is this prefix sum of I minus 1, I'll do a subtraction of them, which means prefix sum of j minus prefix sum of I minus 1. This will give me this range sum value. So 10 minus 1 is 9. So I will get my 9 as a range sum. As you can see, 4 plus 3 7 plus 2 is 9. So by this, in O of one time, by doing a pre-computation of a prefix sum, you can get the range sum, or you can say you can get the sub-array sum in O of one time. So my other problem got reduced. Okay, now I can efficiently find my range sum in O of one time. That is also reduced. So now if I combine my both the logics which I have seen here and here, then what I have to do, okay, I am at the jth, I am at currently at the jth index. I will find the expected value of nums of I have found. Okay, this is the, let's say, expected value 1 and expected value 2. Now in this previous portion, which means up till j, in this previous portion, I will find that that expected value 1, expected value 2, what are the indexes of them. So whatsoever is the, let's name it as I1 and I2. So whatsoever is the expected indexes of them, for those expected indexes, I will go and try on, okay, say, okay, like, then I just say, okay, my one can be I1 to j, other can be I2 to j, expected index, right? So I know that I will have to say prefix sum of j minus prefix sum of I1 minus 1, and the next expected index, it was I2, so I'll just say prefix sum of j minus prefix sum of I2 minus 1. That is, I can actually try. Now, although this might seem simple and this might seem, okay, yeah, Aryan, that is done. That is completely done. But there's a slight catch in this. What is the catch? The catch is that for in a map, in the map, for a nums of I, for a specific value, you will store the index corresponding to that. Let's say I. Now you are imagining that for this, because if you remember this value, what I mean by this is, you will say nums of I, because by you are at the jth index, so you know nums of j, you know k, so you have got the addition, and let's say you have got the value, let's say named as value, so you have got this value which is nums of I. Now for this value which is nums of I, you have to go and find the index corresponding to that, because after this index you can actually find the prefix sum from I to j, because of using this formula, which means prefix sum of I minus prefix sum of prefix sum of j minus prefix sum of I minus 1. You can find the prefix sum formula. So you need to know the I itself. Now, which means one hop is from value to the index, other hop is from index to the previous index, and from previous index to the prefix sum. This is what you want. This is the 3 hops which you will take from value to index to your previous index, which is, you can say, not a hop, and from a previous index to their corresponding prefix sum value. Okay, that seems nice, but what right now you imagined, for a value you will have only one index. But what if I say that Many indexes can have same value. Index I can say, okay, index this index 1 have value 3, index 2, sorry, index 3 also can have value 3. So multiple indexes can have same value. So I can have a I1, I2, I3 and so on and so forth. And same goes for other values also. So if let's say I have to say this is the value I have, which is nums of I. Again, I will have two values, two expected values, nums of I and like expected 1, expected 2. But for one expected value, which is for one expected value, I can have multiple indexes. So Aryan, are you saying that for every index I will go and do a I1 minus 1 and then find the prefix sum and then see what is maximizing my answer? And I will do that for all the j's again and again, which means for this j, for this it is for one j in worst case. You can see, you can try for n i's, you can try for n i's, for next j also n i's. So it can be of n square, which will for sure not work. So there's a slight catch, this will not work because you are doing a hop, which means you are trying for all the possible indexes corresponding to that nums of I value. For a specific nums of I can have many indexes which will give my nums of I value, and I cannot go and try for all the possible indexes here. What is the smart technique which you can apply? If you remembered, this gives you your sum and you have to maximize your sum. Now you are right now at the jth index, so this value is fixed, this value is variable. To maximize the difference between two values where a and b, where a is fixed, then to maximize this difference, what you will be needing, you will try to minimize your b. You will try to minimize your b. So rather than trying on and keeping on all the indexes for a specific value, I will make sure I will keep only that index which gives me my minimum of prefix of I minus 1. I will keep only that index. I'll keep only one for one value. I'll keep only one index, and that one index will be the one which will give me the minimum possible prefix of I minus 1 value. Because you remember, I want the minimum of I minus 1 value. So now that makes sense, but Aryan, still I'm confused between the hops. Okay, from I'll keep the index and then from the index I'll go on. How will I make sure that I mean okay, which data structure I will use to make sure, okay, I'm taking this specific index, and for that index I will have minimum prefix of I minus 1 value. So I'll just say, hold on, don't take tension at all, I am with you. Rather than keeping the indexes itself, keep the minimum value of prefix of I minus 1 for whatsoever, again sorry, for the specific value map. Earlier you were keeping index, but for the index you will need it, or you will want to have the minimum prefix of I minus 1 value. Rather I'll say, bro, hold on, keep track of the minimum prefix sum of I minus 1 value itself. Just keep track of this specific value. And whenever I ask you, okay bro, have you find this value, you say, okay bro, I have found the value, just go and populate this exact map of value here, because this will give you the minimum possible prefix of I minus 1 value, because you have been minimizing this value since so long. So this will give you the minimum value. If it is not even present, which means your map has never been filled. Sorry bro, no worries, move on. Try for next pair. So now if I boil it down properly, then you will see something of this sort. Okay, minus 1, 3, 2, 4 and 5. This is this example. Your k is a 3. Your k is 3, which means the absolute difference between your I and j is actually nothing but this 3. Now if I take the prefix sum value, I will have a 0, minus 1. Again, you have to do a prefix sum pre-computation in the very beginning. This will be a 2, this will be a 4, this will be a 8, and this will be a 13. This is your prefix sum computation. Now I know one thing for sure. I will be starting off from this index. Nah. Why? Because I know I want to form a I and J pair. Now, Aryan, why can't the I and J pair be like this? Bro, look at the constraints. Num's length is this. Your k is more than equal to 1. Now, k was the absolute difference between what? Nums I and nums j. If both are equal, the difference will be a 0. So, k will be a 0. So, for sure, both will never be equal. So, my j will for sure start here. But remember, I will be searching in the previous portion. If I remember, if you remember something correctly, as I showed you in the beginning, this follows your two-sum logic, that for the jth index, find something previously which is having that value. So I will just try to search for this value, right? Value. So I will have to take a map. Now I remembered in my map, for any value, I will keep track of the prefix sum. So I can just, where's the example gone? Yeah, I can just say that, bro, for your this map of I, for this your map of I, which means your map of nums of 0, this will store the prefix sum. Again, this is your I. It will store the prefix sum of I minus 1, which means the prefix sum of I0, it will be minus 1, but by default you can know, okay, it is a 0. Prefix sum of minus 1 is a 0 by default. It's a standard technically, right? If I start my indexing from 0, 1, 2, 3, 4, it is indexing. So this is by default of 0. So this is, I can do initialization in the very beginning. So right now, if I just erase this, so right now I can say my map of my minus 1, which is this specific nums of I, is storing right now the minimum possible prefix sum of I minus 1, which is nothing but my 0. Aryan, what if your this nums of I comes again? Then I will try to minimize this result, because remember, this is storing the minimum possible prefix sum of I minus 1 value. So if new value is coming in, then you will have to minimize it. Let's say in next time some new value is coming in, let's say minus 3. So I'll just minimize that and put a minus 3 instead. I always have to minimize my prefix sum value. Cool. So right now this is here. I am at this index. I am at index this. I know, okay, index is this. Value right now is 3. So expected value is k plus nums of j. K was, if I go back, where is my back? K was a 3. Remember, K was a 3. Right now value is 3. So first expected value is 3 plus 3, 6. Other expected value is 3 minus 3, which is 0. So I expect a 6 or a 0. Let's go and look back. Do I have in my map a 6 or a 0? No, I don't. Okay, no worries. Simply move on, which means move on j. But as you move on, make sure you update your map also with the current value as you do. So now my map of 3 will become prefix sum of I minus 1. This is your I, right? So it will become your I minus 1, which means this value, which is minus 1. Okay, great. Now your map is updated. Okay, this is the value and this is the value. Now your j is here, which is nums of j is 2, k is 3. Again go back, expected, k is 3, nums of j is 2, value is 5, or 2 minus 3 minus 1. Do I have a 5 or a minus 1? Let's go and ask. Do I have a 5? Nah. Do I have minus 1? Yeah, I have a minus 1. Now if I have a minus 1, I can say that right now my sum value will be current, which is prefix sum of j minus what this map has given me, map of minus 1, because this map of minus 1 is storing the prefix sum of I minus 1. So this will be a 0, this will be a 4, so value will be a 4. As you can see also that this, you can see 2 minus 1 is a 3. Absolute difference is 3, and the current sum will be nothing but also a 4. Okay, great. So that is great. Right now my answer, which was I have to maximize the sum. So my answer right now is a 4. It can be or cannot be minimum. As you can see in this example, it is not right now max. Sorry, it can be, cannot be maximum, but right now I know I can maximize my answers. I will simply go on. Okay, great. But as we go on, we have a riti that we will update by j. So map of 2 will become will have the prefix sum of this last value, which is 2. Again, remember this fact: if your 2, which means if your value comes again, this value comes again, you will have to minimize your prefix sum value, because it is coming in the difference and you have to maximize the sum. So minimize the difference. Cool. Now we are at 4. So your nums of j is 4, k is still a 3. So 3 plus 4 is 7, and 4 minus 3 is 1. So value is 7 and 1. Let's see if I have it or not. 7 and 1. No, I don't have it. Okay, simply move on. Okay, I'll simply move on. Move on. No worries. 5. New nums of j is 5. Okay, nums of j is 5. 5 plus 3 is 8. Okay, 8. 5 minus 3 is 2. Okay, 2. Do I have 8 or 2? Okay, let's find out. I have firstly, update your MP of 4 with the value of 4. MP of 4 with the value of 4. Okay, now I remembered I have to find my 8 and 2. So do I have a 8? Nah. Do I have a 2? Yeah, I have a 2. I have a 2 and the value is 2. This value, remember, is a prefix sum of I minus 1. So I know this is a 13 minus 2. I'll get a 9. I'll get a 11. Thus, my subarray sum. Again, I'll try to maximize my answer. Can I maximize it? Yeah, I can maximize it. So update it with the maximum value, which is 4. And thus, you will simply again move on. And when you move on, please update your map also with a 5. And thus, you can see update with the value of 8. And thus, you have got the maximum answer, which is 11. Which is this specific value 11. And that's how you can simply solve it in over n time. Just make sure that how you approach this problem. Firstly, use this concept. Then you linked it with firstly math absolute difference, then to sum, then you use prefix sum, then you realize that it can actually increase the complexity, which means from value to index to prefix sum index minus 1. So then you directly mapped your value to a prefix sum and index minus 1, and that's how you started using that in your answer and try to build your answer. Cool. Let's see the code. It's pretty simple, pretty short and concise. So firstly, you build your prefix sum. Right, again, yeah, the prefix sum right here is 0 index based, because we saw that we can simply make sure handle that edge case in the code only. Again, your prefix sum can be 1 index also, 0 index also. It's totally up to you. Now, if you remembered, that was my nums of 0, and this is my prefix sum of 0 minus 1, which means I minus 1, and I have also written here, it is nums of I map to prefix sum of I minus 1. Cool. Then I'll go on from index 1. Then I will find expected value and expected 2, expected 1 and expected 2. Two expected values which I can have in my answer. Now, if I could have found my expected 1, then I'll try to maximize my answer. Answer is maximum of answer, prefix sum of j minus the map of expected value. Again, if I can find the expected value 2, again same thing, maximize your answer by prefix sum of j minus expected value by using the map. And ultimately, you know that you have to update your map also. So if already I have the value for my nums of j, which means if you remember, I was at specific j. Now I will go on to my next j. But before going on, please update its corresponding map value also. So if right now this nums of j was never inside my map, which means this value was never inside my map, so simply update this value with the prefix sum of j minus 1. But if it is actually inside my map, then try to minimize the value, because you know that my sum is prefix sum of j minus prefix sum of I minus 1, and in future this will become your j minus 1. So this you will have to minimize. So you made sure that you are minimizing your current and the new which you have got. You try to minimize this value because you want to maximize your sum. Simple algebra. And that's how ultimately you will try on for all the possible j's. use a map and simply get the answer. Ultimately, you can simply return the answer whatsoever you have got. But the problem says that if you cannot find, if there is no good subarrays, please return a 0. If you cannot find any good subarray, please return a 0. So I'll just simply make sure that if I cannot find, which means my answer was by default of minus infinity, minus 115. Aryan, why this value is minus 115? Because you can see the constraints are every value, which means all the 1e5 values, if they are minus 1e9, so it will become minus 1e14. So I took my minimum value answer as minus 1e15. Right, that's obvious. So if it is still minus 115, so simply return a 0, else give the answer, and that's how you can simply solve it. Cool, thanks for watching. See you, goodbye, take care, bye bye.